Alright, welcome to this video. This is Mr. Humbard here. We're going to do a short version of the other video I made. So to start, we have this acceleration that could be not zero, even though the velocity is zero. So A could be 0 minus Vi over t, or A could be Vf minus 0 over t. Whatever the case, there's not zero. So for this one, if the object has zero acceleration, it can still be moving, because if we have a graph and if it's a straight line, then it is above the axis. Could be 2 meters per second. Still moving, not accelerating though, because it's just at 2, staying the same. This is a V and T graph. All right, for the third one, this is acceleration because you are moving forward and you have a change in speed over a change in time. 0 to 100 over 0 to 5. For the fourth one, we will know if we are speeding up, slowing down. For this, it's +2, that plus sign matters. So we are speeding up here because it's accelerating at this rate. All right, for this one, the minus sign here tells us we are slowing down. For accelerating, we're decelerating. And over here, we're doing neither because we have 0, not accelerating at all. If we have an object with constant velocity, we have, say, a V and T plot, some, say it's 2 up here, and we go forward in time, it's still 2. So a change in velocity over change in time, say it's 1. 0 to 1, 1 minus 0. It's just going to be 0 or 1 or 0 because we're not changing our velocity. So it has to have change in velocity that's positive for you to have an acceleration, or negative. So the object increases its speed from the average rate of 20 meters per second squared. We want to know how much time does it take to increase its speed from 100 to 180. So let's write this out. We're going to put 180 equals 100 plus 20, so acceleration, because increases its speed at average rate of 20 meters per second squared. That tells us that. Times time. Now we want to solve this out. Get 80 equals 20, t divide 20, divide 20, t equals 4 seconds. All right, 9, object initially traveling, v initial 10, constant rate a, 2 meters per second squared, speed, all right, v final. So it's asking how much time. So let's use our equation. All right, minus bi. Now we're going to do Vf minus Vi equals a t. And here we want time, so we divide out a because that's a multiplication. Then we have time equals change in v. What's v final is 25. V initial is 10. That is 2. So time equals 15 over 2 equals 7.5 seconds. All right. Travels 10 meters per second, 10 seconds. Initial. And then we have that acceleration for 15. So Vf equals 10 plus 2 times our time period that is accelerating. 15. 30 plus 10 is 40. And that's in meters per second squared. Not per second, not squared. It's velocity. Meters per second for velocity, meters per second squared for acceleration. Object accelerates at this rate, meters per second squared. Starts from rest, vi equals 0. Want to know how much time? This is the same equation as up here. T equals Vf minus Vi over A. So we write that out. And in this case, Vf is 20 minus Vi, 0 over Va, 2, or 20 over 2 equals 10. This is going to be a time, so seconds. 10 seconds. All right. For position versus time graph, slope, we want velocity. This is acceleration because it's slope of velocity versus time graph. Oops. Can't write it in. When it's the motion of the object horizontal line, it's at rest. At rest, not moving. Motion of the object, velocity, time graph. It's a horizontal line. It could still be moving unless it's at 0. So if it is at 0, it cannot be moving. It's at 0. It's not moving. But if it's above, it could be, or if it's below, it could be for a V and T graph. All right. For this one, if we have say something up here, we're going to do change in V over change in T, so 3, and this 2, so 3 minus 1 over this 1, 2 minus 0, which is going to be 1. Meters per second squared. And that is the same for both of them. So just 1. 1 and 1. They both have this unit. Alright. For this, we're just going to use negative 9.8. Alright. Initial velocity there, upward is positive. Stone after 1 second. So Vf equals Vi plus At equals 5 plus negative 9.8 times 1. Vi equals negative 4.8 meters per second. All right, for this, we got to be careful here. Start straight up. We only know G and we know time, but that's the total time. So if we half that, we get time to top is at the top, velocity is 0. So V final equals 0. So then we have to use time equals 5, which is half that. Then we can use the equation. So Vf, or the one above, the one up here. So here 0 equals Vi, don't know that, plus negative 9.8 times 5. Use a time symbol or just parentheses, that works too. And then we know VI equals, we add both sides, that value, 49. Meters per second. Okay. Let's drop from a tall building. Takes this object 3.1 seconds to hit the ground. Height of the building is going to be an absolute value, so I'm just going to use that delta x equation. So V initial is 0 because it's dropped. We know that A is negative 9.8. We're going to use positive here because we don't want negative. Over 2 times 3.1 squared. And we plug our values in. We should get 47.089. And I'll just do 47.09 for space meters. For this, object is dropped 30 meters long, so same story. Use the above equation, plug in our values. We're going to do 30 equals 0 times time plus 9.8 over 2 times time squared. Solve this out. We're going to get 30 equals 4.9 time squared. We'll divide both sides by 4.9. We get time squared equals 30 over 4.9, whatever that is, and then square root that. Because we want to get rid of t squared, we want just t. This, I'll put it down there. It's going to give us 2.474 seconds. Alright. This problem, it's kind of poorly written, but we're going to assume it's from 0. So using our acceleration equation, A equals VF, that's VI, over T. It's 100 divided by 0.06 equals, and we'll just put it over here, 16.6 bar. Alright, this one, it's going to be 9.8 because and you can have positive and negative here, but it's just 9.8 velocity because for every second it falls with 9.8 meters per second. Alright, that's it.